Welcome to BPS Visualizing STEAM Mathematics Online Learning Series Session 3.
I'm David Kamishlian, once again from Brighton High School. I'm the math team leader for Brighton High School.
Wonderful. I am Rashmi, Program Director for STEAM Media Arts and CS Initiatives. Welcome, and give us a quick second to move to the presentation. Please do let us know if you don't see or see the presentation or cannot hear the audio into our today's meet. Thank you. Okay. So for the agenda today, we have the questions from your exit ticket 2, which we will look at. We have
the last time we left off, I wanted to show you an activity that was with Desmos, but didn't take any graphing at all. It's a really nice activity that's I'll describe. It's called the penny circle activity.
Absolutely. Next comes the Sketchpad activities, where we will cover a couple of activities: perpendicular bisectors, circumcenter, centroid, orthocenter. We'll look into some Pythagoras, different modalities of that, and then we'll also have a teacher lesson, a classroom lesson on animation that was shared with us last year. So that was a really great piece that we were hoping to show you today.
Okay, and following that, we're going to do a short introduction to GeoGebra, where we'll show you how to start it up, how to construct centroid, and so on.
Yeah, and then comes the fun part, the homework and resources. We'll also have information about the exit ticket. Definitely everything is in the Google Classroom, so please go to the Google Classroom. You can always ask us questions, but first visit the classroom so that you know what's available, and you can probably your question might be answered there itself. Okay. Today's meet?
Oh, yes. So today's meet, so definitely use the Google Classroom for resources. Today's meet is on todaysmeet.com and VizSteam session 3. So today's our third session.
Absolutely. And this is where you can go online and give us feedback, or you can text. This will be live, only for live participants, and great place where you can let us know if you cannot see something or if you have questions about something, and we'll try to address it in the webinar itself. After 3 hours, the link goes down, so it only you can always email us with questions, but this stays on only for 3 hours. Next is to earn your PDPs. We've said this over and over again. Please make sure you view all the assignments, complete all your assignments, view all the webinars, and the final date for
August 10th. August 10th is the final date, guys. So make sure you have everything in August 10th.
Absolutely. Thank you, David. So this is our classroom. You have webinar session 2 information posted. This is the video link to the webinar. It was a little bit longer, so we will adjust that into your PDP credits as well. Make sure you watch it. Today's meet is here, but it is only active for 3 hours, so it's not active for you now. We will post, this is our session 3, so we'll post information about session 3 right over here. The homework is posted. Desmos resources link will be posted. Video links for the Geometry Sketchpad introduction videos are posted, and these are the topics that you will be able to access. And then the link to the exit ticket is also posted. So this is the pattern. This was done for session 1, for session 2, and after this session is over, which is session 3, it will be posted for session 3. Coming back to our presentation, just in terms of the questions, yes, the Desmos activities, we do want to cover more. There was a lot of interest about that, so we'll try to accommodate some more in the next session, which is session 4. Today we are doing the penny activity.
Yes, and then so submissions. we say the honor code here, but really it's you get what you put into it. I sort of use it as a rule, and you've heard me say this before, and I'll say it, and now I guess I'll say it again, is that anything I can use in the classroom, that's what I really look for. And so I push for things that I can, it's not just make work, but it's something I can use a nice list for my students.
Absolutely. And the Google folder link, as David mentioned, it is right in here. It will be posted. That will be the Google folder link. This will be live after the session. It's called Visualizing STEAM _submissions folder. So you can put in resources, you can put in your GSP files or any other specific files or resources that you would want to put in there. SketchUp unit, I know there were questions about using SketchUp. We are hoping to cover a little bit of that in session 4. We do not have much time, but we will continue the series during during fall as well. So we'll have more information and resources on that as well. If not covered in session 4, we'll have more during the fall session. Focuses on K-12 activity.
Oh, okay. Which one? So for the resources? Or?
Yes, you can go.
Oh, yes. So for the resources, definitely take advantage of the screencast. Like if you have something that you've done that you would like us to, share, definitely send us screencasts. There's handouts and the worksheets and links.
Yeah, so all of these are resources you can put in. Any of these, you don't have to do a screencast or you don't have to do a video. Anything that you find useful with your students, as David mentioned, it's important that you've seen some of it implemented in your classroom or have an idea of implementing it in your classroom. And always, K-12 activities are great because, we have a professional learning community of teachers from all grade levels. So anything that you find K-12 is great. That sort of answers some of the questions. Let's go to Desmos. We did have some questions about, how the student aspect of it works, in terms of enrolling students and how that works. So we'll try to incorporate that in the activity as well. David, do you want me to quickly go in here?
Yeah, actually, why don't we go to the first? I think the next slide said the pennies activity. Yeah,
okay, so yep, that is the pennies activity. So let's go to that. Excellent.
Okay, so where we left off in the last session was we did a number of Desmos activities, and all of them involve graphs. And I wanted to just point out that that's not the only way you can use Desmos. And the example that we're going to do today is it's called the penny circle. I like this activity for a number of reasons. First off, it falls in the format of a 3-act math. I want to say 3-act math play that Dan Myers and other people have done. And basically, Act 1 is where you show the students a phenomenon, and they make some guesses. They make a high guess, they make a low guess, or they try and come up with a question that's being asked. And then they make a guess that they think is an accurate guess. And then from that, you look for information. What information do you need? And it might be it's dimensions of something, maybe it's the rate, maybe it's the time, maybe it's the size of something, and so on. And then from there, students work and figure out what they think the answer is, if their answer that their guess they came up was accurate or not, and so on. And they're very engaging. I've done them in my class. That's with the Dan Myers website, 3-Act Math. You can look for that. This activity in Desmos is one of the Dan Myers acts, but it's fit into Desmos. So we're going to demonstrate that. We're also going to demonstrate it with what a student will see also. So I'm just going to say. New session. This activity you can't it was because you have a video. It was hard to preview. So
we could play the video if you want.
I was going to say, if you want to sign in, do you want to open up another tab and you can sign in, and I can sign in here.
Okay.
So it was PPAC is the.
Right. So let me go to. I'm going to open up another tab.
Yeah. And we can show them what you see.
Give me one quick second. So I'm going to open up this act, and I'm already logged in. So I'm going to go in here.
Oh, wait, you want to go to a student though? You want to do students?
So
Desmos student. Yeah, you want
yeah. So let's do. Why don't we play the video and let me go to the. Yes, I can just type here. Desmos. It's student.desmos.com, right? So it is student.desmos.com.
Yep.
And I'm going in here, and what is the code?
It was, I just typed out mine, but
PPAC.
Yeah.
So PPAC, and I'm joining in.
Okay.
And go in. Excellent.
Okay, thanks.
Absolutely.
So this one is different, and I'll just let the video play. This one is different, and the reason why I just want to point this out is, remember, we had done all graphs before. Well, this is a Desmos activity that's initially not graphs.
Yeah, go ahead. So we'll play this. It visually it might appear a bit smaller on your screen, but we'll try to make it maximum volume so that you can actually hear the content.
Okay.
Go ahead.
Okay. And some of you may recognize this from Dan Myers. This is what his video that he did.
Right.
So this is another thing that's really important about these 3-act math plays is that any student can make a guess. Math involved, they can make a guess. So we're just rationally. So I don't know. What do you want to make a guess as? How many pennies do you think there are?
Oh, you make a guess.
I'll say there's, I don't know, 10.
Yeah, you might want to
Sorry.
click in there.
Say maybe 10,000.
1,000. Yep, that's a good number.
And then you're asked to ask what's the number that's too small. Maybe I'll say 4,000. I don't know. Number that's too large. Maybe I'll say 100,000. Did I say 100,000?
Yep.
Now, the one thing that's really nice about this, and I learned at a math conference that I just went to this summer, is that the nice thing about this is that in Desmos, you'll be able to see, let's see, where's our Desmos? Can you pull that up?
Yeah.
I'm going to just sign on as another student here and make another guess.
So I'm going to go to.
Good. Do skip. I'm going to say 20,000. Number's too small. 10,000. So right now I'm just making a guess that. Okay. Let's see. Okay. So and if you notice, here's what the teacher will say, and then I think if I would I refresh this? Yeah.
So if you refresh it,
and then you
can
can
compare models.
Yep, and you can see what people's guesses were, and you'll have this for your whole class. And you don't need to show this to to everybody, because what I learned in the conference is that when people make guesses, they tend to be biased if they hear what other people's guesses are. So if you want them to make guesses, they should make them without taking into account what other people have done, at least initially. So this whole activity has to do with doing the penny. So we've made the guesses. I've made guesses. Rashmi's made guesses. And so the next thing is we talk about a strategy. I'm just going to sort of zip through this, but here's what's sort of the cool thing. What you can do is we can say, oh, I'm going to figure out how many pennies fit into a circle that the diameter is 3.4. And you can change the circle. Maybe we want to make it 4 centimeters, okay? And then you can start dragging pennies in. Tell you what, I'm going to make it smaller just in the interest of time. So I'll make it 2. Keep dragging pennies in. Let's see. And I can't fit 5 in. So over here I put, for the diameter of 2, I have 4 pennies. And I can add that. and we can keep on collecting data here. Then the next thing what we can do is, just because we're kind of, I want to make sure we get to it. You could do this, students could do this a number of times, create a table, and then what happens here afterwards is we'll only see 1 point, but they can have a table of data here, and then they get to pick, do I think this is a linear relationship? And they can drag this line to see if they can make it go through the points. Do I think it's a quadratic relationship? They can drag these points to see if it fits those points. I mean, this, because I have 2 points, it can look linear or quadratic. Or do I have an exponential relationship? And so really just sort of to summarize, what's kind of neat is that after you come up with this, I just went ahead with these predictions for Rashmi. Hers, after we said that, do we think this graph fits the best? It says, okay, when you went out here, here's what the diameter of the circle was. This is what your model predicted. And here's what your guess was, and it compares your guess to what the model is. But it's a really engaging activity that that you want to do, and it does checks on this for checking to see how your guess compares to what your model is, if your model's way off, and so on. But I like this a lot because it compares, it's an engaging task. It allows the students to collect data, and then it allows them to see how mathematics can answer the question for the data, and then come back to their what their guesses were and see, well, were their guesses correct, and how did they verify their guess, and so on. So again, that's this penny activity. It's called Penny Circle.
It's called Penny Circle. Thank you, David. So again, we go back to Desmos, and you have a lot of activities you could browse through. So let's say if you wanted, and give me a topic, David.
There was another one that had. Well, I think a lot of people are going to do. Well, let's say fractions. Let's see if there's something with fractions.
Yeah, fractions. So let's say we have upwards of 4 activities in here, and how they could help in understanding of fractions. Let's look at another.
Well, a lot of things are going to come up for linear equations, or
Right.
Or how about solving equations? Because I know there's a bunch of this.
Right. Or inequalities.
Yeah.
How about that? Inequalities.
There's definitely solving inequalities.
Right. So you have a lot more, again, a lot of visualization, sort of applets, what I call them, that allow you to decipher that understanding for inequality. So you can use them. Again, we suggest if you find one that you use in your classroom and it's helpful to your students, please share the link with us or for the group as well. Good, David?
Yeah.
Okay. Second is we are going into the Sketchpad mode again. We'll be looking at Pythagoras and different forms of it. We'll also try to animate Pythagoras. So let's look at, I'm going to quickly switch to Pythagoras. Yep. And we have, wait, give me a quick second. I'm going to go to that image. Great. Okay, so we are in Geometry Sketchpad, which has, again, I like this whole structure where you have these tabs at the bottom that allows you to browse through different activities. You can have multiple activities related to a concept into one Sketchpad document. So that is also great for portability, for saving, and so on and so forth. So here is your regular Pythagorean theorem. You have area of, this square plus area of this square equals area of this square. And you have that square plus b square equals c square. So you have those formulas associated with it. You can see that this is a scalene triangle right in the middle, and you have your standard Pythagoras theorem. So I can change my a's and it holds, the same holds for this Pythagorean theorem. So we have Pythagorean triplets, So anytime you have these values, you can call them. So let's say 3. I'm going to try to get it to a stage where it's the smallest. Okay, and then you can vary it and see various forms of it. So you can do that. The second aspect of it that I wanted to focus on was dissecting Pythagoras. So sort of we always say, square of 1 plus this square of 1 square plus 2 square equals this one. But then this is a visual representation of how that looks like. So it's like we are going to drag the 5 polygons from here, interior pieces, and we are going to rearrange them such that they actually form the area for this square. So let's look at this square, and I'm moving this part approximately. I'm moving, remember in Geometry Sketchpad, if you select an object, and if the previous object is selected, all of them will be moved at the same time. So here we go. And then there is the the fourth polygon piece that I'm moving, and in comes the last one. So you can actually see that the squares fill up this third square, and so the area, you can see that a square plus b square is equal to the c square. So you can see that. I'm going to reset it. So this is a nice little feature and a visual confirmation of the Pythagorean theorem. Now, this is a special case of a Pythagorean theorem. So you have a right triangle right in between, which is an isosceles right triangle. So both of these, the sides are of similar segments. I'm sorry, and we have a right angle right here. So this is an isosceles right triangle, and if you construct a Pythagoras like this, then you can visually see that this triangle, this square has 2 triangles, 1 and 2, and this square has 2 triangles, 1 and 2, and then 3, 4, and 5. So these pieces, if you see, 4 of these pieces will cover the square. So it is a special case, which is the isosceles right triangle, that will help understand the same concept of Pythagoras, but filling up this area. Last but not the least, we have, give me one quick side. One quick second. Okay, so here is a Pythagorean animation, and if we have time today, we will construct this animation. It does take a little bit of time, but if not, I will of course post the step-by-step handout, activity handout for this in the Google Classroom. So you will be able to play with it and construct it. It does use the animation feature of Sketchpad. So sort of start this activity when you have a slot of time so that you can finish it and sort of enjoy a Pythagorean tree animation. A lot of teachers have used this animation as a like a hook to get students involved into the Pythagorean discussion, and then they sort of get into the whole what does it stand for, what's the definition, and how visually you can prove Pythagoras theorem and also use it in solving equations. So let's look at the Pythagorean tree animation. This is just from a Geometry Sketchpad tool perspective. It also has a variation in terms of colors. So that's one option you can play with and see, because it does, this is a fractal, and a colorful fractal is a really great way of integrating art into mathematics. Just having that. It's a concept of iteration. You have multiple iterations implemented in this Pythagorean 3. And which brings me to the conversation of fractals. We will be bringing in fractals and discussion about fractals, maybe even constructing a couple of them in one of the sessions. So, okay. Having said that, let's move on to the next activity, which is about centroids and orthocenters. Give me a quick second. I'm going to switch to the quick second. I'm going to switch to our activity. So centroid, as you know, are it's an intersection of it's an intersection of medians, and so we will be looking at centroids. We'll be looking at orthocenters. We will also be looking at yeah. Okay. I apologize. I think my presentation is okay. Okay, so we are going to look at centroids and orthocenters, and we'll also look at the circumcenter, which is the intersection of perpendicular bisectors. So give me a quick second. I'm going to move to also in center, which will be discussed in the file. So give me a quick, I'm moving to the Sketchpad window, which will allow us to explore all of these concepts. Okay, and I hope you can see this. Quick second, I'm closing this. Okay, so in here again, I'm going to point out the tabs in the bottom. We'll be looking at centroids, we'll be looking at circumcenters, which are intersections of perpendicular bisectors. We have orthocenter, which is the intersection of altitudes in a triangle, and in center, which is again intersection of angle bisectors. So let's look at centroids, which are medians, and medians are basically segments which are connecting the vertex or vertices of a triangle to the midpoint of the opposite segment. So that's F is the midpoint of AC. So is this. So we are going to label this. Let me give it a name. And labeling this one as well. So E is a midpoint of BC, segment BC, and D is a midpoint of segment AB. So these are medians. So BF, AE, and DC are the medians of this triangle. And I can move this around, and you can see that the centroid stays put. So no matter how I move it, whether it's equilateral, scalene, or isosceles triangle, this will stay put. And you can see that P, which is, it's essentially, that is the property of a centroid. If the medians are intersecting at a point and that, stays put, especially when you're constructing it. So we're going to try to quickly construct the same centroid in here. So let's take 3 points, 1, 2, and 3, right? For our triangle, I'm going to select them, and I'm going to construct. Segments. Again, this is retaining my line style, so I'm going to make it thin, and I'm going to make it solid. So that's my triangle right there. Now I need to construct a midpoint on segment EF. So I'm going to construct a midpoint on segment EF, which is called G. I'm going to construct a midpoint on segment DF called H, and I'm going to construct a midpoint on segment DE. So now I have 3 midpoints. I'm going to now construct F and I. So I'm going to construct a segment right here. Sorry, so I'm going to give me 1 second. I selected F and I, and I'm going to go to my construct menu and construct a segment. I'm going to do the same with E and H, and I'm going to construct a segment. Same thing, I go to D and G, and I construct a segment. So I have 3 segments. Let's see if I need to see if this thing, yep, it is staying put. And then I'm going to select segment, 3 segments, which are EH, DG, and FI, and I'm going to construct, let's see, I'm going to construct an intersection. Now let's see if J is put. Yes, it stays put. It is an intersection of these 3 segments. And if I move my triangle, just like the one before, just like this one, the intersection, which is the centroid, and I'm going to change this label to calling it centroid. Okay. So this is, J is my centroid for the of these medians. So I can construct that, and that's how I did that. You could do this with circumcenters or orthocenters and incenters, but here is a really nice table where it keeps track of your distance, like BCE, that's your distance, and CE to F. So it's a ratio of B to CE, point CE, which is centroid, and then point CE to F. And you can see that, you know, it's sort of the slope of this line, which is plotting all the points here, stays the same no matter how you change your triangle. So that is a really good discussion point or exploration for students. So they plot this data, and then they, you know, they get the data, they plot it, and they see that the slope actually stays the same. So the ratio stays the same. Now we go to the circumcenter, which is essentially perpendicular bisectors. So you have, these are perpendicular bisectors of the segments of the triangle. So let's see, E is bisecting the segment AB into, it is perpendicular to that segment, and it is also bisecting that segment. Same is with the segment BC, and you can see that the line passing through D is bisecting BC and is, you know, it's also perpendicular to that. So anything, you know, the intersection of these 3 perpendicular bisectors will give you a circumcenter, which is this. And when you draw a circle with that, that will show you that it inscribes that triangle within it. So if I even change the dimensions of this triangle, the circle will always, the triangle will always be inside that circle. That is the circumcenter property. Now we will look at the, so this is about orthocenters, which is altitude. So these are essentially the heights of the triangle. They're perpendicular to the triangle and is the height of the triangle, and the intersection of that gives you the orthocenter. And incenter is where the circle is inscribed inside the triangle. So incenter is essentially the angle bisectors. So this angle B of this triangle is bisected by this line, and you can see that these 2 angles, angle B, angle A, B, and if you have a point C out here, F out here, then that angle, this angle, and this angle are equal. So they are, angle B is bisected by this angle bisector, and the intersection of those angle bisectors is going to give you the in center of this triangle. And you can see that this circle will always stay within that triangle, no matter um, how you vary the distance of these segments. So yep, I'm just modifying it right here, and you can see that that's a neat little way of documenting, and you can see that the variations in that will change. Okay. Excuse me. Okay, having said that, we are going to move on to our next set of exercises, which is we are going to look at, give me a quick second. While we do this activity and we've built a centroid, we are also going to build a centroid in one of the other examples, which is the GeoGebra, and we'll go to it in a quick second. But before that, I wanted to quickly share this amazing lesson Mr. Nguyen shared with us. Thank you, Mr. Nguyen. This is an animation lesson that he uses with his students, and he stated that one of his students helped create this because they play a lot with the tools within Sketchpad and love animation. So this is a really great screencast session, and I just wanted to share that with you. We'll also post a link to this lesson. It's a video, so we'll post that in the Google Classroom. Give me a quick second while I switch to this. We are going to look at the lesson. Okay. Please let me know if you cannot hear or see any of this onto the today's chat, today's Meet chat, so that we can correct it at our end. So here we go.
In this video, I'm going to show you how to do animation in Java's Sketchpad. If you follow along with me, you'll be able to do this animation by the end of this video. And I believe that this will give you ideas on how to create more interesting animations in Sketchpad by yourself. Now let me show you how this was done. Begin by opening a new sketch. Next, using the segment tool, create a triangle. Label this triangle. Then using the select tool, select each side of the triangle. Side AC is already selected. Then you go to construct midpoints. Now label these midpoints using the text tool. You can change these labels if you want by double clicking on the point, but I'm going to leave these labels as they are. Next, using the circle tool, we're going to create a circle centered at D with radius DA, and also a circle centered at E with radius EC. Now we're going to use the point tool to create a couple of points on these circles. And next, using the text tool, label these points. Using the select tool, we're going to select A, G, B counterclockwise and go to construct arc through 3 points. Now double click outside the construction to unselect everything, then select the large circle and select point G. We can hide these points, going to display and hide objects. We're going to repeat this procedure on the other side. Select BHC counterclockwise, go to construct, arcs through 3 points. Unselect everything, then select the large circle and point H, go to display, then hide objects. Now using the point tool, we're going to create 2 new points. These are going to be on the arcs. We're going to label these points using the text tool. And now using the select tool, double click outside the construction, then select point I. Move it around. You notice it moves on the arc. This is exactly what we want. Now using the segment tool, construct the segment ID. Now choosing the select tool, double click outside to unselect everything. Then choose the segment tool to create a small segment outside our construction. This will serve as radii for a bunch of circles. Now choose point A, and with the segment selected, construct a circle with center and radius. Repeat this at point I, so you have another circle centered at I with that segment as the radius. Now we're going to highlight the intersections of these circles with AC, AB, and ID. Label these intersections using the text tool. Next, after unselecting everything, create the segment LK using the segment tool. Since this is already highlighted, go to select and then point M. Create a circle centered at M with LK as the radius. I'm going to adjust the previous segment we created to control the radius a bit. And now select the intersection of circle I and circle M and label it. Using the select tool, unselect everything. Then we're going to hide the extraneous stuff. We only want to keep that point N. Hide objects. And next, click and hold the segment tool, then choose the ray tool to create the ray IN. And now choose the select tool. Unselect everything, choose point I, try moving it around. You notice that we've copied the angle A at I, and it moves as we want it to. We're going to do the same at J now. Select the segment tool now and create the segment EJ. Using the select tool, unselect everything, then select the small segment we created. Select point C, construct a circle by center and radius. Do the same at J. Construct a circle with that segment as a radius, and now highlight the intersection with CB, CA, and EJ. Now, using the text tool, label each of these intersections. Using the segment tool, create the segment OP and use this as a radius for the circle centered at Q. So construct a circle by center and radius. Now highlight the intersection of circle Q and circle J. Label it. Now again, just like before, we're going to hide all the extraneous stuff. We're only keeping point R. Display, hide objects. Now again, choose the ray tool by holding on to the segment tool and construct ray JR. Using the select tool, unselect everything and move this around, and you notice again you've copied the angle C at J. Notice that the rays extend indefinitely, and for visual purposes we only want it to go to F. So using the segment tool, construct the segment FC, and using that segment as a radius, construct a circle centered at J by going to construct and circle by center and radius, and then unselect everything and select FC and point I, and construct a circle by center and radius there. Highlight the intersection with the rays. Now label them and unselect everything, then selecting the segment tool, construct the segment IS and JT. Now we are ready to hide things. Select the rays, the large circles. We can even hide the arcs now. And we're going to hide point R and point N. And also the segment FC. Go to display, then hide objects. Also now, AC, we would like it to be solid as the other sides of the triangle as well. So go to line and solid. We're going to hide the small segment as well. Now you notice that we have what we want. Now all that's left is animation. And now let's do it. I'm going to move this to the side and create room for some animation buttons. We would like for I to move to B. Selecting those, go to Edit, Action Buttons and Movement. You don't need to do anything here. Just select OK. We would like J to move to B. So select them in that order and go to Edit, Action Buttons and Movement. Again, there's nothing to change, just press OK. Now, we would like these movements to happen together after we click a button. So select both of these buttons, go to Edit, Action Buttons and Presentation. Change the label for this presentation to Show Presentation or anything else that you might like. Then press OK. Now before anything else, let's create the reset as well. That'll be when I moves back to A and J moves back to C. So let's select I, then A. Go to Edit, Action Buttons and Movement. Reset movement, we want that to be instantaneous. Okay, do that and press OK. Select J, then C. Oops, make sure you've unselected everything. Select J, then C. Then go to Edit, Action Buttons and Movement. Make the movement instantaneous as well. And then select OK. Now selecting the two buttons we just created, go to Edit, Action Buttons and Presentation. This movement is for reset, so enter reset, then press OK. Now let's test it out. Show presentation seems to work as it should, and so does reset. Now click Show Presentation and quickly stop it. We want to label the angles now. Using the marker tool, click and then drag. Click at the angle, then drag inwards. Okay. Now, using the Select tool, we would like to select pairs of angles and color them the same. So go to Display. After selecting, then I'll color these red. And angle J and C, I'll color them, let's see, green. Okay. And angle B, I'm going to leave it as it is. Another test shows that this is running as we want it to run. Now, at this point, the labels are just kind of getting in the way. So I'm going to hide most of the stuff. So leaving Show Presentation and Reset and dragging it close to our construction. We also want to hide all the labels in the construction. So what you want to do is select each point. Go ahead and do that. Then go to Display and hide labels. Okay, we're done with our animation.
Thank you again, Mr. Nguyen. That was really very helpful. I will have this screencast shared with you on the Google Doc, I'm sorry, Google Classroom. So please feel free to use this as and when you see fit in your classrooms. We'll quickly move on to the next activity, which is, one quick second. So we just looked at the animation lesson. This is incredible because it allows you to play with a lot of tools and sort of processes within Sketchpad, and allows you to build advanced animations or sketches in Sketchpad. So do feel free to explore more. We will have a continuation of this learning series, the Visualizing STEM. We'll have multiple sessions that sort of delve into more advanced animations or projects that deal within the Sketchpad ring. So moving on to the next one, please make sure your portfolio example, as we have been using, there is a Pythagoras portfolio, there is a parabola portfolio, where you have multiple activities combined into one. That's a great way of keeping all of these concepts together for students, and they can look at it in different variations. So this is the student e-portfolio template is for you to use. You can use it in your classroom. You do need Sketchpad for that, so do let us know when and how many you need, and we will definitely install that for you. On to the next one, we will be going to GeoGebra as promised. So let me quickly switch to GeoGebra. That is your version of GeoGebra that is available to you free. What I wanted to quickly refer to was this is Caitlin's reflection about Sketchpad and GeoGebra, and she uses both of them. She finds Sketchpad very useful in her classrooms, and GeoGebra is a great tool that mimics many of these aspects of Sketchpad. GeoGebra is free. For Sketchpad, you do have to pay for a version of Sketchpad, and of course, you have to. With payment comes the much more flexibility in terms of implementing different models and sketches in Sketchpad, so it can be stretched. But GeoGebra is a great tool that you can use in your classroom as you are exploring many of these sort of graphing, calculating functions, or even playing with sort of different concepts and visualizing those in your classroom. So what is GeoGebra? So it sort of makes it, again, all of these form a pattern of tools that make math more tangible. It has multiple exercises that you can use in the geometry or algebra or pre-calc classrooms or even calculus. And this is just sort of a visual way where students can experience mathematics and can see mathematics. In terms of the setup, you have materials that you can explore, and we'll explore it in a bit. This is where you start GeoGebra, and you can get into the into GeoGebra setup. And this is about download. So we're going to quickly go to the download page and see what's available to us. So GeoGebra, there is a version for a tablet, and you can download it here. For desktops, it works on Chromebooks, which is great. You have Windows, it works on Macs, it also works on Linux, and there is a GeoGebra version for your phones. So it's a pretty flexible way of implementing it in the classroom. Now, if we go into the materials section, you can research. There is a slew of activities that you can research, or you can search materials. So you can search by worksheets, or you can, let's say, linear. And I'm going to try to type in here. It's not letting me type. Give me a quick second. So, Yes. So in here, if you type in linear, you should be able to see a slew of materials that um, allow you to interact with the linear models that are in here. So for example, there is also a way of browsing through the activities right in here. You have a tessellation activity. If you want to go into the Hilbert's curve, which is sort of or Sierpinski's triangle, they are in here too. You can construct tiny spirogyras, that kind of stuff. And if all you have to do is sort of click, this is a linear activity, you can click on the activity. It allows you to get into the activity. You can favorite it, so it will be available to you. You can share this material with others, or you have other options such as downloading it. You can make a copy of it and add different things to it, like specific equations and stuff like that. It has a very similar interactivity in terms of you can like in this case, you can add a new line, and what is the equation of that line, and sort of minus 4x minus 2. So let's look at, yep, and then you will have to probably move it around, and you will get, oh, yes. So just move it around, and you can position it, and you can play with it. You can change certain parameters in here, so on and so forth. So let's go back to GeoGebra. I'm going to go to the setup, which is, I'm going to start GeoGebra, and when I do that, I go into this setup. Now, there are many ways in which you can use, this is the arrow tool that moves or selects or drags objects. This is your point tool, so you can object, you can intersection, you can build an intersection point, midpoint, complex numbers. So this is all available to you in your sort of your browser. So that's why you can use it in Chromebooks. Midpoint on a circle, you can have the intersections. This is the line segment. So here you can build a line, a segment with a particular given length. You can do more advanced stuff with it as well. You can build perpendicular lines by selecting a point, parallel lines by selecting a point, bisectors, angle bisectors, the way we learned about it just a minute back, where we talked about, what is the intersection of angle bisectors, and that circumcenter is the intersection of all the perpendicular bisectors for a triangle. So things like that. This is your triangle tool, polygon tools. You can do regular polygons or vector polygons and circles, ellipses, so on and so forth. You can even do some reflections and have some text or function inspectors and relationships embedded in it, and then you have sliders. It's very similar to Sketchpad, and to a lot of people, they say GeoGebra is a modified version of Sketchpad, and they have used a lot of these ideas and made it available to be used on Chromebooks or other apps. So in here you have this nice little icon where you can have the you can have your coordinate plane or not, or you can have the coordinate plane and the the grid, so you can draw accordingly, and then you have your home. This option gives you snap to the grid, so you have specific equations or points, you can do that. This is your settings menu, and then you have more options right here, where you can have spreadsheets, or you can have probability calculator, graphics, 3D graphics, so on and so forth. So I'm going to turn this off. I'm just going to keep the grid. And right now, let's, for the, just to play with it, we are going to play with a triangle and then build a centroid. So if I'm going to do, let's say, I'm going to draw a triangle. So as you can see on the left hand side, my points coordinates are visible. Then I'm going to and then I'm going to draw the third point, let's say, yep, right here, and then back here. So that's my triangle, and you get the algebraic function or the coordinates of that triangle. You also get You can value, and you can do, you can define and value it, or you can add descriptions to it. Now, my job is to, I have this point, so I'm going to do a midpoint for this triangle. So let me go here, and I'm going to draw a midpoint. All I did is select a midpoint from here, and I'm going to draw a midpoint right here, and I'm going to draw a midpoint for segment BA. Now that I have my midpoint selected, I'm going to select point A and this point, and I'm going to build a segment from this to A, and I'm going to build a segment from B to B, and then I'm going to build a segment C to small c. Yep. So that right there is my centroid. And that's a great way of constructing it in, and you can see that I achieved the same result in here. It's a pretty cool, neat trick. So that was your GeoGebra in quick, a quick activity about GeoGebra, and we are going to quickly go through. That's what we did. I wanted to take a minute to see if we could, to see if we could listen to Nick's draw versus construct explanation, because it's very, it's wonderful when he mentions about how important it is for students to be able to construct an activity in Sketchpad, and how that impacts, you know, being able to draw and being able to construct. What are the differences? So I'm going to quickly switch to that, and give me a quick second. Okay, and we are going to play this.
Classroom, in every group of kids first experiencing Sketchpad, is the idea of draw versus construct. Is your activity and is your product a drawing, or is it something in which you've thought about the mathematical definitions that define the shape? And there's lots of research that says that this is a stage that every student goes through as they begin to develop a dynamic conception of mathematics. So let me show you an illustration of the sort of distinction that I mean when I say the distinction between draw versus construct. If we asked a student to construct a square, and that student doesn't have prior experience or prior sort of deep experience thinking about dynamic geometry, a very common type of behavior for the student will be this. They'll use the tools, like I'm using the straight edge now, to put together a picture of something that looks like a square. I'm pretty good, so mine looks very much like a square, but if it didn't look perfectly like a square, maybe they'll even drag some pieces of it to make it more square-like, or measure the sides and drag them until all four of the measurements are equal. And they'll say, there, this is a square. Or maybe if they're mathematically precocious, they'll say, this is a square, and the fact that all the measurements are equal proves that it's a square. But it's not a square. And if you ask your students at that point, what happens if I drag a corner? Watch what happens if I drag a corner here. Obviously, as soon as I start dragging that corner, the whole square breaks down. Because when I created this shape, I didn't give it any of the mathematical definition that's essential to a square. All I did was connect 4 points. Now, if you think mathematically, what does it mean to have 4 connected points? It means you have a quadrilateral. Squares are quadrilaterals, but so are rectangles and parallelograms and trapezoids, and here's a cross quadrilateral. I can drag this shape into all sorts of things that aren't squares because I didn't construct it as a square. I drew it as a square. So then you have to have your students begin thinking, what are the properties of a square and how can I put them into my image in such a way that when I drag a piece of it, it'll always stay square. So that when you do this drag test, your students don't say, don't do that. Instead, you have a square that always stays square. So if I wanted to construct a square in Sketchpad, maybe one thing I'd look at is I know squares have right angles. So I'll put a perpendicular line here. and construct a perpendicular line. Now, whenever I drag this point or this point, that line is defined, it's constructed to be perpendicular to them. And similarly, if I use a circle whose radius is the same as the base, then all radiuses of this circle are exactly that same length. So what I'm going to do here is use the circle to give me a length perpendicular to the base that's equal in length to the base, or a segment equal in length to the base. So you can see where I'm going with this construction. What I've done is I've put together right now two perpendicular equal length segments. That's the first half of my square. To finish off the square, maybe I use perpendiculars, maybe I rotate something or use reflection. Many different properties I could build in, but I have to think about what's going to make a square so that no matter how I drag it, it always stays a square. And there, this time I used two more perpendicular lines and wind up with a square that when I drag it can be as big as I want and oriented however I want. But there's no way I can make that anything other than a square. So there's a huge difference between these two shapes. The one on the left is a quadrilateral that happens to be square. The one on the right is a shape which is constructed to be square. And that's the difference in a nutshell between a drawing and a construction. It as a square. I drew it as a square.
So that was Nick's explanation and the sort of emphasis on the importance of draw versus construct, and really recognizing that mathematical definitions are core to constructing a mathematical shape, or even recognizing that. And within Sketchpad, students, while doing constructions, really have to think about it and have to implement mathematical definitions in order to achieve the desired effect, or in this case, building a square which passes the drag test. So thank you, Nick. Moving on, every session we are emphasizing on this. All the activities sort of align really well with the new MEDLCS standards, such as digital literacy, computer science standards, and obviously the mathematics standards, but sort of keeping in mind the computational thinking, this a concept of being able to algorithmic design, and sort of what and how these activities can impart that extra learning objective to the students is a great way of looking at it. And we have this whole list of MEDLCS standards posted on the Google Classroom, so please do take a look at it and use it as a planning tool. Again, these are our learning series objectives. I constantly like to go back to these and sort of re-emphasize, why we are doing this. So sort of being able to explore multiple representations and ways of problem solving, and being able to utilize the interactive dynamic natures of these tools in offering understanding or teaching for understanding for your students is really a great way of looking at it. And students are forming hypotheses, they're arriving at conjectures, they're testing their conjectures. That's a really great way of learning about mathematical relationships in multiple ways. Homework, you have an exit ticket. We have the assignment, so you'll be completing the penny circle activity assignment in Desmos. Of course, do explore GeoGebra, and if you have, we have a hope that you will share a resource that you use in your classroom with us and with the professional learning community, and also sort of share a link to a Desmos or Sketchpad activity from the resource. And then again, as resources, we will post Sketchpad tips, we will post videos from the upcoming series, and we will also post the Sketchpad introductory videos. Thank you again. Always go beyond and explore. Complete your assignments. Make sure you are learning, sharing, collaborating, and exploring together. And do not forget to share the amazing resources that you are using with your students, because that's something that you find useful is equally useful, or possibly more, to your colleagues. Our next session will be a live telecast on Wednesday. Please feel free to join us for the live telecast, or you can always watch the video after the telecast and you can complete the assignments. Everything is posted in Google Classroom, and the final due date for all assignments are August 10th. Thank you again. Thank you so much. This is a big thank you from David and me, Rashmi. We hope that you will join us for the next session, and have a great day. Thank you.